Good morning children. Chapter 14 Statistics. Last class we have seen about two types of the frequency distribution, ungrouped frequency distribution and grouped frequency distribution. In grouped frequency distributions we have seen like this, one grouping we are doing, based on that we are arranging the data and we are making a condensed form. Now let us learn the terms related to this. Class interval we are telling, because the group we are telling, generally we can use that it is a class interval. It's a range 30 to 35, and here 30 to 35, 30 is the least value and 35 is the highest value. 30 is called lower limit of this class interval and 35 is called upper limit. Similarly, 35 to 40, if we take, 35 is the lower limit of the second class interval and the 40 is called upper limit. So the least value, what is called least value of the respective class interval, it is called of the class interval is called lower limit, and the highest value or the greatest value of the class interval is called as a upper limit. So respectively they are called as a 30, 35, 40, 45. And here what will come, 30 won't come there, 35 से start होता है, 40, 45 and then 50 will come. So we got lower limit of the first class interval, second class interval, third class interval and fourth class interval. Here upper limit of the first class interval is 35, second is 40, third is 45 and the last one is 50. Correspondingly the frequencies are 9, 5, 2, 4. That means the frequency means number of times each observation is coming. So now we got the terms lower limit and the upper limit. The next point we have to learn about this one, that what is a class mark. Class mark means midpoint of the class interval. So that is lower limit plus upper limit divided by 2. That means 30 plus 35 by 2 equal to 75 by 2. Sorry, 65 by 2. Next, what is the second class interval class mark of the respectively? The second one is 35 plus 40 divided by 2. It is equal to 75 by 2. What is the next? 40 plus 45 divided by 2, it is equal to 85 by 2 and so on. One more only we have to write, I'll write that also. So 45 plus 50 divided by 2, it is equal to 95 by 2. So what is the answer we are getting here? It is 32.5. Next, 75.2, what is the answer? It is 3. 75, 37.5. Now you can see that 32.5 and 37.5, 5 is the difference. So naturally, what is the next will come? It is 42.5. You can cross check with this one, and 42 plus 5, it is a 47.5. So these are the class mark of the first class interval and the second class interval, third class interval and the fourth class interval. Now we can see that what is the class size of this one. What is the class size? The difference between means lower limit, upper limit, greater number minus lower number, upper limit minus lower limit. So it is equal to 35 minus 30 equal to 5. Similarly, another example is 40 minus 35, that is equal to 5. So class size, or we can call it as a class width. So these are the terms associated with it. Now one more point here, that is that we have to learn that when we are saying that 30 to 35 and 35 to 40, 35 will be counted where? So 35 is coming 2 times. Here also it comes, here also it comes. Where it will be counted? The 35 will be counted here. That means these upper limit portions are excluded. This is excluded. Upper limit. All upper limits are excluded. So what we can say that it is a continuous frequency distribution or exclusive, means that the upper limit is excluded. So here 30, 35, 40, 45 are included, whereas 35, 40, 45, 50 are excluded. So continuous frequency distributions, upper limits are excluded. So these are the points related to a grouped frequency distribution table. Now let us see one more type of grouped frequency distribution table, how it is. Next one is inclusive or discontinuous frequency distribution table. You can see the class interval sometimes like this also. 31 to 35, 36 to 40, 41 to 45, 46 to 50. That means there is a break. It is not a continuous one. So that is why its name is that a discontinuous. What is the meaning of inclusive? When we are talking about like this class interval, meaning is that the lower limit 31 and the upper limit 35 are also included here. The counting will take place here only, and here also 36 to 40 the scores will be counted here only. 36 also included, 40 also included. That is why we are telling that it is inclusive frequency distribution table or a discontinuous frequency distribution table. Such a question is given to you, we have to convert into a continuous one. How we can convert that in a continuous one? Just to take the difference of the upper limit and the next succeeding lower limit. What is the difference there? 35 and 36, 1 is the difference. That divided by 2. So we will get that 1 divided by 2, 36 minus 35, you will get a 1. Again, what is the next step? 1 divided by 2, we'll get it as a 0.5. So 0.5 will be added to the upper limit. That means upper limit became 35.5. Naturally, the second class interval's upper limit will be 40.5. Again, 45.5. Again, the last one 50.5. Now, what will happen to the lower limit? Lower limit we have to subtract that one. That means 31 minus 0.5, it is equal to 30.5. Here 36 minus 0.5, it is 35.5. Here there is no need of thinking from second class interval onwards, because this upper limit become the next lower limit. So here it will become 40.5. And you can cross check 41 minus 0.5, it is 40.5, and here 45.5. So we got here the continuous class interval. Now you see there is no break. 35.5 and 35.5. Here 40.5, here 40.5. 45.5 ends here also it starts with that only. So that means there is no break is there. It is a continuous class interval. That means whenever we are having a discontinuous frequency distribution curve distribution table, we have to make it a continuous. After seeing the difference of the lower limit upper limit of the first class interval and the next succeeding class intervals, lower limits difference to be taken and divided by 2. Then similarly 40 and 41, what is the difference? It is 1 only, 1 divided by 2. So the uniformity will be maintained. Now you see 35 minus 31, what is the difference there? The class width we will get as a 4 only there, but here 35.5 minus 30 we will get a class difference as a 5 only, but that uniformity throughout the class interval will be maintained there. So what here the lower limit is called 30.5 and the upper limit is called as a 35.5, and with this new one, what is called a true class limits, the new conversion is called as a true class limits, whereas respectively true class lower limit, true class upper limit. So when we are having a discontinuous frequency distribution table, we must convert it into continuous frequency distribution table. The value of pi up to 35 decimals are given below, 3.141592653 etc. Make a frequency distribution of the digits 0 to 1 after the decimal point. That means here it is an ungrouped frequency distribution table we have to make. Lower classes we have already studied this pattern. So it's a we have to make a table. First one is a digits 0 to 9, you should write 0, 1, 2, 3, 9, and then the total column. Frequency after the decimal point. So 1 how many times? means we have to see that it is 2 times. Again 0 is coming 1 time, so like that 2 you check, it is here 1 2, again here 5 times it is there, here 4 5. Have you seen this? Like that each digit to be calculated, and you have to make this one. You can take the help of the tally mark also. Now we have to make a table for this one. What is the column? We have to give digits and the frequency, and more important, what is the last column should be written? Total equal to 35. So 35 decimals should satisfy. So each digit you should check how many times it's occurring, that is your frequency. So 0 is coming only 1 time, 1 is coming 2 times, 2 is coming 5 times, 3 6 times, 4 3 times, 5 4 times, 6 3 times, 7 2 times, 8 5 and 9 4 times, total 35 times. You can make a complete table after drawing that one, and it's good while presentation to be good only. So draw the table correctly. So which type of the distribution table we have done here? Ungrouped frequency distribution table we have done here. Next question. The scores out of 100 obtained by 33 students in a mathematics test as follows: 69, 48, 84, 58, 48, 73, and it is up to 69 only. Here also we have to represent a frequency distribution table. Represent the data in the form of a frequency distribution table. So we have to draw a table, and each score you have to check. And then 48 if you check, you can see that 3 times it's coming there, 58 3 times, 64 4 times, 66 7 times, 69 6 times, 71 3 times. Like that you have to make the table. And one more column we have to write that a total should be done. This is a total equal to 33. Then only our table will be complete. The total should be added here. So 33 students are there, 10, 17, 23, 26, 28, 29, 31, 33. So this should be added, then only it is correct. So the data in the form of a frequency distribution table we have made. It's an ungrouped frequency distribution table. Here tally mark you can add or you can avoid also. The marks obtained by 40 students of class 9 in the examination is given below: 12, 8, 18, 8, 6, 16, 12, 5, 23, 2, like that. 40 students mark is listed below here. What is the question? Means represent the data in a frequency distribution using 15 to 20 as one of the class interval. In question it may give the hint that we can give the class interval 15 to 20. That doesn't mean that it should be the first class interval. Always identify which is the lowest value and which is the highest value. So just cross check which is the lowest value. 1 is coming here, right? So the 1 is the lowest value. Now anybody got a 0 there? It is not there. So 1 is the least value. Similarly, which is the highest one? We have to check that once. It is 23 is coming in this row, and 23 here also. There's 24 is there. So 20 up to 25 we can make, because 15 to 20 the 5 is the class width is there. So represent the data in the frequency distribution using 15 to 20. This idea to be used, and we can decide the class interval. For that we should identify which is the least value and which is the highest value. From this we have identified that 1 is the least value and 24 is the highest. So we can prepare a frequency distribution table with the help of a tally mark. So the first column is class interval, and the next column is tally mark, then frequency. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. So 15 to 20 came here, right? So when they had given the option doesn't mean that it is the first class interval. So the first readings are, I'll just write here, 12, 8, 18, 8, 6, 16. So we will read 12. So against 10 to 15 we will mark one tally mark. Again 8 will come here, 5 to 10, 18. it will come in 15 to 20. 8 will come again here, like that. 6 here, and 16, 15 to 20, like that. We have to put the tally mark, and final we have to make the total. So 4 tally mark means 4, here 11 and 8 observations. This group have 9 observations and 8 observations. Now what is the point here? I want to say that when we are doing the tally mark, after the 5 group, means once 5 is completed, leave some space, then second group should be started. Now what is the meaning of this 11? 11 observations are lying between 5 to 10, right? So that means we can count from 5, 6, 7, 8, 9. All these observations are coming under the group 5 and 10. 10 will be calculated where? Here only. The tally mark for 10 to be put here only. So that a point I already explained. With this you can cross check that total 40 is coming or not. Then we can prepare a frequency distribution table. This time it's a continuous frequency distribution table. So with this, today's class I am winding up. One is ungrouped frequency distribution table we have made, and another one is a continuous frequency distribution table.